Hello, I'm Kayla Flager, and I am here to explain the experiment that we're doing today, which is creating a baking soda and vinegar volcano. The experiment today involves combining baking soda and vinegar, which are two household items, and the idea is to create a volcanic effect where the baking soda and vinegar reaction kind of spews out of the bottle that it's going to be taking place in. Vinegar, which is also known as acetic acid, is going to be combined with baking soda, which is also known as sodium bicarbonate. We already know that acetic acid is a weak acid and sodium bicarbonate is a weak base. So we're going to see what happens when those two react with one another. We need just a couple of materials for the experiment today, things that most people have, around their house. And the first of those is going to be baking soda, which again is the base in this reaction. We also need vinegar, which is the acid in this reaction. We need a water bottle, which is where the reaction is going to take place, and we need a paper towel to put the baking soda inside of. My hypothesis for this experiment was that the reaction is going to occur and one of the products would be water. I hypothesized this because we know that this is an acid-base reaction, and with an acid-base reaction, one of the products is always H2O or water. I also expected there to be an extreme reaction between the baking soda and the vinegar that would cause the product to bubble up and come out of the bottle, kind of shoot out like you would expect when a volcano were to erupt. So I started this experiment by rolling up the baking soda into the paper towel, and I dropped it into the bottle. I then poured the vinegar into the bottle with the baking soda and watched the reaction occur. When I combined the reactants, the reaction did not occur to really the extent that I expected it to. But it was clear that there was a reaction. The baking soda and vinegar combined to create a lot of bubbles. There was a lot of white, kind of, milky liquid until it had a chance to settle out a little bit. So there was a clear chemical reaction taking place, though, as I said, it did not occur quite to the extent that I expected. And there's a couple reasons that I think that this might have happened. If I were to do this experiment again, I would do a couple of things differently. First of all, I'm not sure if I might have used too much paper towel to wrap up the baking soda in. I thought that it would, help keep the reaction contained until I was ready to be able to observe and see it take place. But now looking back, I think that I used too big of a paper towel, that there wasn't quite enough time for the vinegar to be able to react with all the baking soda. When I removed the paper towel from the bottle, there was still some baking soda that had not reacted. So I think that using a little bit of a smaller piece of paper towel could, potentially increase the results of this reaction towards what we were expecting to observe. And also, I did not close the bottle in the reaction, so I think that if I had closed the lid on the bottle, even if it was just loosely closed, that the pressure would have been able to increase in the bottle until it was no longer able to really contain that pressure, and it would have popped the lid off, and we would have seen some of the overflow of the product in this reaction. So as I said, the results didn't turn out quite as I had anticipated. However, it was still visible that a reaction was taking place, and it was still neat to kind of see that reaction occur. So we know that the acetic acid and the sodium bicarbonate reacted with one another, but let's take a look at a little bit of the science behind what happened and why it happened. So basically, we knew that this would be an acid-base reaction since we're combining an acid and a base. We knew that H2O would be a product of the reaction because the hydrogen from the acid is going to combine with the hydroxide from the base to form H2O or water. That's something that always takes place in an acid-base reaction, and this, of course, is no different. If we take a look at the chemical equation, we can see here that we're combining sodium bicarbonate with acetic acid. The ultimate products that we end up with are CO2, H2O, and also sodium acetate. So we're going to end up with 3 products. One's a liquid, one's a gas, and one is an aqueous solution. There are 2 steps that take place in this acid-base reaction, and the first of these is a double displacement reaction. So with the double displacement reaction, we have the acetic acid reacting with the sodium bicarbonate. The products that come out of that reaction are sodium acetate, which we can see here, and we also end up with carbonic acid. Carbonic acid, which is represented as H2CO3, is unstable in this state, so it immediately occurs in a decomposition reaction where the H2CO3 ends up becoming carbon dioxide and H2O. It decomposes into 2 separate products that we end up with. So we're going to see that the final products of this reaction are CO2, carbon dioxide, H2O or water, and then the sodium acetate. The CO2 in this reaction is immediately released into the air, and then what we have remaining in the bottle is the sodium acetate and the H2O. In my experiment, as I said, I did not put the lid on the bottle, which didn't allow any pressure to build up. The CO2 was immediately released into the atmosphere. So I think that if I could have left the lid on the bottle, or if I could have done the experiment again and put the lid on the bottle tight enough that the pressure from that CO2 could have built up, I think that my results would have been a little bit different with this reaction. So thanks for watching and have a great day. Bye.